Patty Simpson with Simpson Math. In this video, we're going to use Bayes' theorem to help us solve a probability problem. So here we have a certain virus that infects 1 in every 200 people, or it has a 0.5% prevalence. And a test used to detect the virus has a sensitivity, a true positive, of 80% and a specificity, or a true negative, of 95%. We want to know what's the probability a person with a negative test result has the disease. Now, originally, the probability when the person went to the doctor, the probability that they had the disease was 0.5%, or 1 out of every 200 people. But what Bayes' theorem tells us is that once we have new information, our probability or our thinking changes. That's what Bayes' theorem says, is that we're looking for the probability of an event, given we know the probability of another event. Now, we could use this formula to help us find that probability, but I actually find that it's easier to find the probability and use Bayes' theorem if I create a two-way table to help me out. Now, we created this two-way table in a previous video, the link for which is down in the comments below. So here we've updated our thinking with the fact that we now know that the person got a negative test. Once they have a negative test, now we want to know what's the probability that they have the disease. So in the denominator, we want to know, so first the notation, we want to know what's the probability they have the disease given that they got a negative test. So Bayes' theorem itself, what it does is it says, what's the probability we get that negative test? That's going to be in our denominator. So we're going to look to see the total number of negative tests, because that's now the population, the total population we're looking at. We're only interested in those ones with a negative test. Then we want to know what's the probability they have the disease. So only looking at these guys, the probability they have the disease, well, there are 20 of those that have the disease. So the probability that they have the disease, given they got a negative test, is 20 out of 18,925. The probability they have it is really, really tiny. It's about 0.1%. So you see our probability changed. Before we started, it was 0.5%. Now that we have a negative test, we know that the probability we have the disease is 0.1%. Math made simple at Simpson Math. Thanks for watching.